In this video involving the binomial distribution, we're going to consider or look at one-tailed tests. So let's take an example. The standard treatment for a particular disease has a 2/5 probability of success. A certain doctor has undertaken research in this area and has produced a new drug which has been successful with 11 out of 20 patients. The doctor claims that the new drug represents an improvement on the standard treatment. Test at the 5% significance level the claim made by the doctor. So a one-tailed test will always be an increase or a decrease in something. Now, if we underline the key aspects of this question, the doctor was claiming that it represents an improvement on the standard treatment. So we need to now make an hypothesis test. And so what we say, well, H0 is called the null hypothesis, and that's that the probability remains the same. There's no difference. That's 2/5. And that H1 is called the alternative, which is in our case the doctor's claim that P is an improvement or greater than 2/5, as in more patients are getting cured by this new treatment. So what we state to the examiner, this is a one-tail. Now because it's greater than, we say it's a one-tail upper test. If it was less than, we would say it's a one-tail lower test, respectively. So in our case, we've got a one-tail upper test, and then we go back to the question and state, okay, they've told us that 11 out of 20 patients, he's observed that, so we call this the observed value. That's what he's seen or she has seen. So what we then do is we say, well, alpha is called the significance level, and we're going to say that's 0.05 because it's 5%. And then what we say, we calculate the probability of X being greater than or equal to the observed value. In our case, the observed value is 11. So we're going to work out the probability that X is greater than or equal to 11. So I've taught this to you in previous videos. You do 1 minus the probability that X is less than or equal to 10. We can get that from our calculator quite easily. So we get our calculator, go to menu, option 7, go down to binomial CD, to 2, and X in our case is 10, because don't forget you read that as X is less than or equal to 10, because binomial is a cumulative distribution or a sum of probabilities. N in our case will be 20, because we've got 20 patients, and the probability was 2/5, so 2 divided by 5. And that will give me 0.87247. So 0.87247. And so on. I've shown how to calculate these. You store that in A. Go to 1 minus alpha and A. And that will give me 0.1275. Now here's the important part. We want to compare this probability, or what's known as a p-value, to the significance level. Now whenever your p-value is less than your significance level, then you would reject the null hypothesis. If your p-value is greater than your significance level, you would not reject. So in our case, we say since 0.1275 is greater than 0.05, we state we do not reject H0 at the 5% level, and we must state this: we have insufficient evidence to suggest that the new treatment is an improvement in comparison to the standard treatment. You must answer the question in context to the way they have asked the claim, and it must be in context and answering that in particular. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. So what we're going to do is the following. We're going to write our model that x follows the binomial, that we've got 12 trials, and the probability of getting a 6 is 1 over 6 is our probability of success. Now notice that our observed value is that only 1 6 appeared. So I'm going to state here that the observed value is 1. And now we need to set up our hypothesis test. So the probability remains the same, which is 1 over 6. But if we notice, the alternative is there any evidence that the probability of a 6 on this dice is less than a 6? So remember, one-tailed test is always has a direction, either greater than or less than. In our case, it's going to be less than, so less than a 6. So we say it's a one-tail lower test, and that alpha is 0.05. So now what we can do is say that the probability that x is less than or equal to the observed value, in our case is 1, and we can type this onto our calculator. So move my calculator over here. So menu option 7, go down to binomial CD, variable. So you want less than or equal to 1, n is 12, and p is 1 divided by 6. And that's going to give me 0.3813. So 0.3813. So we can say since 0.3813 is strictly greater than 0.05. Remember, you only reject the null hypothesis if your p-value is strictly less than 0.05. So in our case, our p-value is greater than 0.05. So we say since 0.3813 is strictly greater than 0.05, we do not reject H0. Now we can conclude that since 0.3813 is greater than 0.05, we do not reject H0 at the 5% level of significance. We can say level of significance, and we can say we have insufficient evidence to suggest the dice has a probability of less than 1/6 in regard to obtaining the number 6. Please, my clarity in my handwriting there.